All right, welcome back to the last 8 problems to do here. Wrote them down separately so we can just go to them instead of having to keep going back and forth to look here. So, all right, so for number 7, obviously our left-hand side is definitely what we want to work on. So let's turn sine into sine over 1 times tangent is sine over cosine plus, let's make cosine a fraction by putting that over 1, and all that should equal 1 over cosine. Okay. Well, when we're multiplying, we've got to put these two together first here. Okay, put those two together first. So that would give me sine squared over cosine plus cosine over 1 equals 1 over cosine. Well, again, when we're adding, we have to get common denominators. So our common denominator would be cosine. Okay, cosine times 1. In the first fraction, my denominator didn't change, so my numerator will change. But in the second fraction, we don't have a cosine in the denominator, so we have to multiply both the denominator and the numerator and denominator by cosine to get plus cosine squared. And then we know, here again is this identity, that's 1, so I'm not going to write the answer over here. So we get 1 over cosine of theta equals 1 over cosine of theta. Check. Okay. Number 8, all right, I'm definitely going to look at the left-hand side. You have a couple different ways that you could approach this. You could use Pythagorean identities to expand both the tangent squared and the sine squared. What I'm going to actually do here in this problem, and looking at my answer, I don't have a sine or cosine on my answer, so I apologize. I have a tangent in my answer, so I don't want to use my Pythagorean identity. So I know tangent squared, let's change colors here. I know tangent squared can be written as sine squared over cosine squared all over sine over 1 minus 1 So here I gotta do keep, change, flip. So I got sine squared over cosine squared, first fraction of sine. Change division to multiplication. And we flip 1 over sine squared. So minus 1 should equal tan squared. Okay. So what do I know here? I know that sine squareds are going to cancel out. We're going to work up here. So I'm going to get 1 over cosine squared minus 1 equals tan squared. Right, so going from here to here. Well, what is 1 over cosine squared? Well, that's secant squared. And square minus 1 again equals tan squared. What is secant minus 1? Well, that is indeed tan squared. So we get tan squared theta equals tan squared theta. Check. Okay. Excuse me. All right. Number 9. Well, obviously, the left-hand side, we want to work on that. In this case here, again, you could do one of two things. You could look at this right here and say, oh, wait a second. I know that that is secant squared. Probably the easiest way. And I still have my cosine squared out here. So if I multiply these, well, again, remember, I am multiplying a function by its inverse. And whenever you multiply a function by its inverse, you'll always get 1. So you could distribute that one too. Distributing will be a little bit more work, but recognize the trig identity, the Pythagorean identity more so, in the parentheses, and it'll make this problem a lot easier. Okay. Number 10. Number 10 actually is very similar to, what is it, number 4. It's the same exact problem. But at number 4, what I did was I changed the left-hand side. I changed this side to make it secant squared, and then made it 1 over cosine squared. So in this one, let me show you what happens if you want to do it the other way. In other words, instead of working on this side, let's work on the other side first. Okay. Well, I know that 1 over cosine squared is secant squared, and don't change the other side. And then what do I know about secant squared? Well, I know that secant squared is tan squared theta plus 1 equals tan squared theta plus 1. So that problem there was done 2 different ways in number 10, and number 4 shows you how to do it 2 different ways for each of those problems. Okay. All right, let's move on to number 11. Number 11 is similar to what we did above, but it was with cosine squared. So again, same idea here on the right side, I have a sine squared. On the left side, I have a sine and a cosine. So if I want my left side to look like my right side, I need to get rid of that cosine squared. So, yeah. So if I'm doing that, I want to make this sine squared minus, well, I want to turn cosine squared into sine squared. So in parentheses, very, very important, that needs to turn into 1 minus. Well, now we can distribute. I get sine squared minus 1 plus sine squared. Should again equal to sine squared theta minus 1. Well, can I combine these two on this side to give you 2 sine squared of thetas plus 1 equals 2 sine squared theta plus. It's a little sloppy up here. I'm sorry. I did my math wrong. This is not supposed to be a plus, nor is there a plus on this side. That's where I think I made a mistake. It's a minus 1, so it's minus and minus. Check. Check. Okay. A couple more to go here. All right, for number 12, again, sort of the same idea as the one that we just did. If I look on the left-hand side, I have just a cosine squared. But on the right-hand side, I have that cosine and a sine. So I'm probably going to want to change this. So this time I'm going to leave the left side alone. So 1 plus cosine squared equals 2 cosine squared plus 1 minus cosine squared. Now in this case here, you don't have to have parentheses around the 1 minus cosine squared, just because of the fact that it's an addition in front. Only when it's a minus, like in problem 11, do you really need the parentheses there. So all I have to do is on the right-hand side, combine my like terms. I have a 2 cosine squared minus a cosine squared. Well, doesn't that just give us 1 cosine squared plus 1? Check. Remember, I've said it before, addition is commutative, so it doesn't matter the order in which you write it if you want to make it look exactly the same. But 1 plus cosine squared is the same as cosine squared plus 1. Okay. And the last two. Got these separately here, a little longer. So number 13, we got tan squared minus sine squared equals tan squared. Tan squared minus sine squared equals tan squared times sine squared. So think about this problem. Again, you got subtraction, you got addition. Probably going to want to work with the subtraction. Let me think ahead here real quick. Yeah, let's do that. Let's work with the subtraction here. Meaning, tan squared turns it to sine squared over cosine squared minus sine squared over 1 tan squared sine squared. So on the left-hand side, we have subtraction, so obviously we need to get a common denominator, which would be cosine squared, right? Cosine squared times 1. The denominator in the first fraction didn't change, so the numerator stays the same. So we got sine squared minus. Now I have a sine squared there, but I need a cosine squared in the denominator. So when I do this, it's going to give me sine squared cosine squared. That should equal here. So my numerator right here, if I look at my numerator now, okay, I need to try to simplify this. I guess I could. Let me show you this. So when I do that, I could factor out a sine squared from both terms in the numerator to get 1 minus cosine squared all over cosine squared. That should equal tan squared sine squared. So now if I look at this, what I can do in looking at my answer, I could separate, now this is multiplication, you can still do this. I could do sine squared times cosine squared. Actually, no, I apologize. I can't do that. I'm sorry. I'm thinking of addition now. I could separate it into two. Sorry about that. So what I want to do is I can think, oh, well, this is sine squared. I know in parentheses, isn't 1 minus cosine squared also sine squared over cosine squared? Now look at my answer. I need a tan squared. I need a sine squared. Don't I already have a sine squared right here, which will match that? And then what is sine squared over cosine squared? So that'll give me tan squared, sine squared. Sorry. Tan squared theta times sine squared theta equals tan squared theta times sine squared theta. Something about this, a little bit longer. 1, 2, 3, 4. I guess that's a 5-step problem right there. So that one there, a little on the trickier side. There's again a couple different ways you can really approach this problem. I just showed you one. And for our last problem. So our last problem, number 14 here, really again sort of shot in the dark as to which side you want to pick. Hold on 1 second. Sorry about that. I'm back here. So for the last one again, if I look at the left-hand side, I have 2 trig functions. On the right-hand side, I really have 3 trig functions. So it's probably going to be better if we work on the right-hand side. Sine. What I recommend doing is tan sine plus tan by cosine. Sorry about that. Here. Here, tan, don't forget, is sine over cosine times sine over 1 plus sine cosine times cosine over 1. Remember, I'm doing nothing to this side, so let's leave this alone. That's what I want to get it to look like. But on the right side, nothing special happens here, so I do get sine squared over cosine. But here, if you notice, well, you know what? In this case, and again, I know sometimes this is a little tricky in figuring this out, but I could cancel out the cosine, but I'm not going to do that because I want to keep my denominator the same. Okay? So I'm going to keep it like that for now, which means I'll get the sine 1 plus tan equals all over cosine, and I get sine squared plus cosine. So this is a lot like the last problem now, because when I look at this problem, I now look at my numerator here. What can I do in my numerator? I can factor out a sine. So let me bring this up here. So again, I have the sine 1 plus tan equals, if I factor out a sine, ooh, that looks good because I have a sine over there. Don't I get, don't I get sine, if I throw sine, sorry, I get a sine plus cosine all over cosine. I don't know if this is the right way to do this problem now that I'm looking at it, because this is not going to lead me to my answer. Factor out a sine to get sine plus cosine. Now I see it. I'm sorry. Did not quite see it, but now I do. See, it happens sometimes. have my sign that I need in my answer. There's my sign. What I'm going to do here is in parentheses, I'm going to separate sine over cosine plus cosine. And we can do that with addition or subtraction when you have one term in the bottom. Okay. So what does that give us? That gives us sine of 1 plus tan equals sine of, well, guess what? Isn't sine cosine tangent? And isn't cosine. So that one there, a little tricky. Stumped me for a second, but I got it. But there are the answers. I don't have anything on the last page. I don't know if I need an extra page, so I just put that there. But there you go. Okay, there you go. So those are the review. You will get your quiz. It'll be opened on Thursday morning, and then again, you have until Sunday night to finish it. All right. So please let me know if you have any questions. Otherwise, thanks for listening.